and welcome to Cracking the Cryptic from the Bat Cave today. We're going to look at this puzzle, which is in a series of puzzles by Alaric, Taqi, who we featured on the channel before, but along with Crusader 175. And I think he's going through a whole alphabet of ideas, and this one is E for entropy. So we'll look at that in a moment. We've done puzzles by Alaric before. We've done puzzles using this entropy constraint before, but we'll see how it goes. Don't forget that there's still time to enter our Patreon competition 3 times a Sudoku. Don't forget also that we've recently updated the Killer and Thermo apps, and they're getting rave reviews, the updates. So check into those. There's loads of links under the video to all the stuff associated with the channel, merchandise, Sven's SUDOKU PAD, the apps, Patreon, Discord, etc., and all worth checking out. But this puzzle, as I say, it's called E is for entropy. I don't know what A, B, C, and D were, but E is for entropy, and the entropy rule, for which I think Alaric thanks Mid-Tias, who came up with it, I think. But anyway, normal Sudoku rules apply. Consider the low digits 1, 2, and 3, middle digits 4, 5, and 6, and high digits 7, 8, and 9 as 3 different groups. Each 2x2 box in the grid must contain at least 1 digit of each group. So in this 2x2 box, we must have one of those 3 low digits, one of those 3 middle digits, one of the 3 high digits, and another one from one of those sets, obviously. But it is a really fascinating constraint. Puzzles that we've done with this constraint have worked really interestingly in the past. So I'm looking forward to this. It's highly recommended. Do give it a try on the link under the video. You may be able to judge from the video length how hard it is, but I am going to have a go now. Let's get cracking. And the first thing I'm going to do is color the blessed numbers. So let's make the middle ones yellow. The low one's blue and the high one's red. Why not? Primary colors, hot and cold, that makes sense to me. Okay, so what do we learn from that? Let's consider 2x2 squares. Well, we're going to need a red in that pair. And we're going to need a red in all of these dominoes because otherwise they're just yellow and blue. Similarly, we're going to need at least 1 blue in all of these. That's not actually all that helpful. Right, 2 blues there. So we're going to need a yellow and red in those 2. 2 reds here. Some good symmetry in this puzzle. We're going to need a blue and a yellow in those. Now, these yellows, well, potential yellows, would have to be the 5, and that wouldn't work in either position. This is lovely. Straight away, this is lovely. Look, there's a 2x2 box here which needs a yellow digit. There's a 2x2 box here which needs a yellow digit, but there's only 1 more yellow digit to go in box 5. So where can it go in those 2 and those 2 that's shared? It's got to be in the middle. So that's the yellow one. These 2 are not yellow. We now know they're red and blue. So this one has to be yellow in this 2x2. In this 2x2, the yellow has to be there. And we've got some colouring done. That even must be a 5. I've even got a number in the grid. Okay, so what next? Now we need a red at least around in those 2, a blue at least in those. In these 2 we need a blue and a red. In these 2 we need a blue and a red. Oh, trouble is drawing it like that doesn't really reflect the way that the dominoes together must work. So maybe I'll leave that out. Yes, and up here, look, it's very good when you've got 2 numbers diagonally, 2 colors of the same diagonally touching, because they use up the double in that 2x2. So this has to be red. This has to be red as well because of that blue and a yellow. This one is blue. Look, the symmetry is lovely. This one is blue. This one now is red because there's 2 blues there. This one is blue because of the 2 reds. Getting lots of this coloured now. And that probably ends there, but what have we got to now? Not much. I can't really do any numbers, I don't think. I'm not sure what other colours I can do. Now I've done this sort of square area. I know there's a blue there. I know there's a yellow in those two because of this 2x2 area. But this can't be yellow because all the 3 yellows in this middle box have been done. So that's yellow. Same here, that's yellow. Same here, I think. Yeah. No, it's not. Yellow and... Yes, it is. For this 2x2, it is exactly the same. For this 2x2, we need a yellow. It can't be there, so it must be there. Same here, that's yellow. So these are all yellow. Look, I can number them now as well. 6, 4, 6, 4. And this one's a 5. And this one's a 5. Wow, so that's a whole bunch, whole lattice of yellows numbered. Now what's happened here? Oh yeah, this is a red and a blue. This is a red and a blue. Don't know how to deal with them. Okay, that's fine. Right, what next? We need a yellow here and a yellow here. So this can't be yellow because that'll be the second yellow in the box. That'll be the third. Oh, look, I need a blue here. Right, little 2x2's not complete, and I can complete them all. Look at that, a whole bunch. The symmetry is wonderful. I wonder how the symmetry is ever going to unwind here so we can finish the puzzle in a unique way. Anyway, now 2 yellows there. Oh, so this is blue and red as well. That's blue and red. 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 There's tons of this stuff around. What? How do I use it though? I'm not sure I understand how to use that. All of these cells are blue or red in various pairs. And that doesn't tell me what this is, because that could be a blue-red pair. Or could it? If that's a blue-red pair, I don't really see. Oh, look, 7 and 7. They're ruling out all those cells, so I can do Sudoku. Put a 7 in there. Is this is a 3, because that 3 and that 3 ruled out all of those. That's weird. That doesn't necessarily make this a 3. It makes one of these two a 3 and one of these two a 7. The 3 doesn't have to be here just because that's a low digit, because that could be low too. Then that would be high. That would be low. That would be high, and the box would work. Oh, this is strange. I bet that's a 2, but I don't know it. 6, 3. One of these is a 7, and it could be obviously there. One of these is yellow. One of these is yellow. That is probably red, but it could be blue. There's blue here. Yeah, all of these boxes have the same. I've got 6 boxes with a 2x2 in. They all kind of have to have the same sort of thing. Yellow and yellow must be in those dominoes, and that's not yellow. Red and red must be in those, and that's not red. I don't know how this helps. Blue and blue must be in those, and that's not blue. Yellow and yellow there, that's not yellow. Blue and blue there, and that's not blue. And as I keep saying, I don't know what to do with that information. I'm missing something here. So there's definitely red here. If it was there, that would use up red for the whole row. Oh, that's nice. Right. Right, there is a red in one of these two because of this 4x4. Yes, I think this is going to apply everywhere. This is really interesting. There is a red in this 2x2. So it's either there or there. There must be a red here, so they're not both red. Now, if this was the red... Oh no, I thought this worked. No, I was getting my numbers mixed up. I thought, for some stupid reason, I was thinking 6, 7, 8 was a set. If that's a red, though, that would have to be red. Because both of these 2x2s would need a red, so they'd have to share it there. So I think this is probably not the correct version, but I don't know why not. Maybe there's somewhere in the grid where that obviously won't work. It's more likely to be in box 4 or 6. So if that was red, 8 or 9, no, if that was red, 8 or 9, that would have to be red. Then the third, no, I don't know where the third red would be. Oh, bother. Oh, yellow. Yellow's the one where I've got 4s, 5s, and 6s. Yes. Yes, here, look. If this was yellow, there must be yellow in one of those two because of this 2x2. If that was the yellow, it would be a 4. Now these two would have to share the remaining yellow, so it would be there. But if that's a 4, this can't be 4, 5, or 6. So that is not where yellow is. Yellow is there. And I think by the same token, this can't be yellow because this would be 6, and then that can't be 4, 5, or 6. So yellow is also there. And I think we're going to see this sort of pattern repeated everywhere and interspersed with that. But we have to work out why. Now this 4x4 needs a red. That's why there. So these other two are blue. We now know where 7 goes. It doesn't go in a low cell. So we'll take that 7 out. We'll write 7 in there. Now down here, yellow, if yellow was there, it would be a 6, and then you couldn't put a yellow here. So that is not yellow, that's yellow. Same here, that can't be a yellow 4 because that can't be 6. So we get yellow there. Now this needs to be blue for its 2x2. These both need to be red to make up the numbers. That's not 7, that's not 7 because of these given 7s. So that's 7. This is a 6. No, it's not a 6-8 pair. It's an 8-9 pair. What is wrong with my triples? That's an 8-9 pair. I still don't know about these. Now this, that sees 3 colours. Bother. All of these cells see 3 colours, which wasn't what I wanted. Right, there's a 7 in one of those two. There's a 3 right there because it can't be in red. So that's 1 or 2. Now that must be replicated. Yes, 3 and 3 can't be there, so 3 is there. That's a 1-2 pair. This is a... I can do the 4 and 6 up there. But I can do these yellows. Yes. 4 and 6. This is a 1-2 pair. So yellows are good. Everything else is sort of gradually resolving into pairs. Now, that can't be yellow because this couldn't have a yellow then. So yellow 5 is in one of those two, and therefore one of these two. One of these is blue, that's not interesting. 3 is in one of those two. That's the symmetrical opposite to that 7 that I got. What next? There's a blue here. The second blue for the row. I suppose there might be a third as well. Oh, 6, 6. We can place 6 in this box. There it is. We can probably place 6 in box 3 as well. Can we do 4? Yes. Can we do 5? I'm sure we can. I'm not sure we can. It's in one of those two. Oh, that's weird. Is there a reason it has to be there? I'm sure it is going to be there. Could we put 5 here and here? Can't see any 2. Let's colour that. I can't see any 2x2s that fail to have a yellow, even though I don't think that's how the 5s will dispose. Now, this area needs a yellow, and it's got to be a 5, and it can't be there, so it's in one of those two. And that puts 5 in one of these two. And down here, can we? Yes, we can do 4 in this box as well. Can we do 5? No. Again, it's a pair. Ah, but it's a pair looking at that cell, so that's... Yes, I could have done the same up here. There's a 5 pair looking at that cell. So we place 5, and those are all yellow cells. Right. Now, one of these, blue in... No, it's red in this box. One of these is red, and one of these is red. So I think they both have to be red-blue dominoes now. That's right. So if that's a red-blue domino, the third red in the column needs to be there. Now that must work here as well. If that is a red-blue domino, and it must be because of there's a blue there and a blue there, that's a red-blue domino, so the third blue is there. So in this row, one of these is red and one is blue. Oh, I don't know which. Oh, that. Oh, that's interesting. That is 1 or 2 as well because of that 3. So that's forming a pair. So this is a 3-9 pair. Is that? I don't think that's any use. It's a strange puzzle. This doesn't work. That is going to be 8 or 9. The symmetry's here again. The symmetry is almost too strong in this puzzle for me. I just don't see how we're ever going to disambiguate it all. It's weird. Right, now, let's find... We've still got these yellow, like this whole... I was going to call it a trellis, but I mean a lattice of reds and blues that are one of each in diagonal pairs. I don't know how to resolve them yet until I get one of them. I don't see how I can do it. Sorry if it is obvious. It's not to me. There's a 7 red in one of those cells. What next? That's 8 or 9. That's almost certainly 3, but I can't write that in yet. If that was 2, that would have to be 2 by Sudoku. That would be 2. Is that the sort of way to... It would make that 1, and that would be 1. I don't know, it's just sort of following a trail around. I mean, it might work for something. Six. Oh, what? Okay, let's have a look at the ones that surround this 6. Whatever that is, blue or red, that will be different. Ah, so those will be different, blue and red. Those will be different, blue and red. And that means, since that's constant between them, those are going to be the same colour, either both blue or both red. That means these two will be the same as well. Oh, the same colour. Just looking at that 8-9 pair that they would see, does that mean they can't be red? No, they could be an 8-9 pair the other way round. Botheration. How? What in the heck next then? Okay, these are the same. These two. These two are the same as well. Is that better? If that was a 3, that's a 1. Then 3 is going to have to be there. 2 is going to have to be... I'm not sure. There's a 1, 2, and an 8 or 9. A 1 or 2 and an 8 or 9 here. The same is true here. And here, and here. Ah, look, this one, let's give it a flash of green, is the same 8, 9, not as this one, so it is the same as that one. Therefore, that green thing appears here somewhere. And it doesn't appear here, it appears here somewhere in box 6. Therefore, it's in one of these cells. And I bet we can do the same. Yes, look, this blue, let's call it blue-purple, is not the same as that. So it is the same as this. And it's not in those cells, so it is in these cells. So they're sort of green-purple now. And again, it's not in those cells, so it is in those cells. So they're green-purple. And this pair is green-purple, which means they're different. One is high and one is low. Ah. So those two have to be different in terms of high and low as well. These two are different. One is high, one is low. Those two are different. Those two are different for this 2 by 2. Those two are different, so these two are different. Oh, I don't know what this means. I don't know how to use it. These two are different height and lowness. One is high, one is low. These two are different. These two are different. That means these two are different. I don't know what use this is. It's something to do with this again. It is. Now, I said those had to be the same earlier. Okay, let's randomly choose. Oh, my colouring is going mad now. Let's just remember that these are purple and green. And let's use different colours. Make that orange. Sorry if you can't see it against red or something, but okay, let's make it grey. Now, that has to be different because of this 4 by 4 in terms of high or low. So that can be, what if we use, oh, I'm going orange now, sorry. Orange there. Now that has to be different. So that's grey. That's orange. This one. Oh, these two are different. That's what we found out. So that's orange. Now we know whether orange is blue or red from this 4 by 4. If it was blue, you've not got any red in there. So orange is red. That's red. Grey is blue. Sorry for the mad sentences here, but we've worked it out. That's blue to make up the numbers. The 7 is red, is there. The 3 is blue, is there. Oh, my goodness, that's madness. Now, this whole trellis, yes, that one is blue lattice, not trellis. That one is red, so we know whether it's 1 or 7. It's 7. And we can fill that in. This is a 1. This one is low. That's a 3. That's a 9. That 9 is obviously high. I can't remember the colour. It's red. 1 is low, is blue. We're getting there now. Oh, do we know? Look, this has to be blue for this 2 by 2. Yes, of course. This is a red-blue domino. Oh, I don't know which way round they go yet. Maybe I do, but I can't see it. This one, though. Ah, that's a 2 since we got the 1. Yes. So that's a 1. So I don't know if I need these purple flashes anymore. I don't think I do. I think I've used them and the green flashes. So I'm going to get rid of those. Do I know about 8 and 9? I must have done something. Yes, 9 there. Yes, 8, 9, 9. I don't know about this pair any more than I know about that pair. Right, never mind. We get a 1 in one of those two. It's got to be in the blue. This is not a 3, so it's 1 or 2. Oh, in fact, it is a 1 because 1 can't be there or there. 2 is in one of those two. Anyway, never mind about 2. We get 2 there, 1 there. This is 8 or 9. There's probably a way of doing, yes, that's the way of doing that. 9, 8, 9. That's a 1. So I think I've coloured almost all the cells that I've got coloured. I've numbered almost all the cells I've got coloured. Just weirdly that pair not done. Oh, I can do that from this row. 8, 9, 8, 9. Okay, let's keep the colors going because I know some people like that a lot. That's blue, that's 2, that's 8, that's red, that's blue, that's 2. Middle 3 rows all done. I think I'm just finishing off now. This has been epic. What a clever puzzle. I mean, so weird. I think Alaric said something in his email about coloring to achieve the right coloring or something. And I sort of see what that means. Towards the end with the flashes, we had to do Sudoku coloring to achieve the entropy coloring. I'm certain that's what it means. And that is a very clever concept. If a little bit chromatically confusing, let's say that. Right, now, this is a 5. What have we got? 7 and 2, just the bottom row to do. That is an 8. And let's color it all up before we hit the last digit. Blue in those 2. That's yellow. And there we go. This should finish the puzzle with a 3. There we go. What a brilliant idea. E is for entropy, and that is a fun puzzle. Hope you had a go at that. Very entertaining and a delight to do. Hope to see you soon again on the channel. Bye for now.